welcome to HydroMaster's CDS xDrive Service Training Video Series Part 4. In this video we're going to cover the electrical system on the xDrive, specifically the use of the capacitors, just the theory of operation, how the electrical system works, some of the main components, and then we'll go over the electrical schematics. So to start with supercapacitors, there's a series of 24 supercapacitors used in the xDrive to store enough energy to initiate the operation of the machine. It also provides some smoothing of the voltage produced by the generator. Capacitors are housed in 4 modules, and the 4 modules are connected in series. So you get a total capacitor voltage rating of 64.8 volts. Capacitors are charged by the van's battery while the engine is running. These capacitors have a very low internal resistance, so they will self-discharge when they're not being charged. So you remove the charge and the capacitors will lose their charge slowly. Sometimes it takes up to 8 hours for them to completely discharge. When they are fully discharged, to charge them up takes approximately 8 minutes with the charge system on the capacitor pack. The capacitors are located underneath the machine cover, behind the motor controllers, and right above the blower. So you can see it in this image, kind of in this little hole here behind the motor controllers. So the function of the capacitors, as I mentioned, was to provide the initial voltage for the controllers to begin operation, and to provide a little bit of smoothing of the voltage. So there's a little bit of variation in the voltage created by the generator, so the capacitors help to smooth that out. The motor controllers will initiate operation at about 24 volts. However, at 24 volts, there's not enough power in the capacitors to keep the machine running, so we generally advise to not start the machine until capacitors are charged up to at least 32 volts. The design of the capacitor pack, again, is 4 16.2 volt modules. They're connected in series, so it gives us a capacitor pack voltage rating of 64.8 volts. In the capacitor pack, there's also a 12 to 48 volt converter. That's what we use to charge the capacitors up. They're only charged when the van is running. So they're charged off the van battery, the 12 volt system in the van, but only when the van is running. And then as soon as the machine is turned on, that charge circuit is disabled, so we don't overcharge the capacitors. In the capacitor pack, there's a 7.5 amp fuse in the negative charge wire. This is to protect the converter from being damaged by voltage spikes. There's also a relay in the capacitor pack that turns the charge off and on based on whether the machine is on or off. And there's also a resistor. The resistor is there to limit the current, the charge current, to about 2 amps. Safety with capacitors. The capacitors need to be fully discharged prior to any work being done on them. There is some hazard of arcing, some shock hazard. Primarily, they say with capacitors, it's a burn hazard because they will discharge very rapidly. Much like a battery, if you short out a battery, positive to negative, you will get some arcing. You also get that with capacitors, but they're capable of very high current. So anytime any work is to be done on the capacitor pack, they really should be discharged completely. We'll go over that discharge procedure. You can test the voltage of the capacitor pack. You can do it with a multimeter, but you can also use the gauge that's on the front of the machine. The gauge on the front of the machine will read the voltage of the capacitor pack down to about 5 volts, and then the gauge stops reading. So at that point, you do need to use a multimeter to test the voltage on the capacitor pack and try and get it down below 2 volts before you initiate any work on the 48 volt side of the system. So the discharge procedure, so using again the gauge on the front of the machine or a voltmeter, measure the voltage between the positive negative terminals on the capacitor pack or the positive negative bus bars on the controllers. If the voltage is above 2 volts, then you need to connect a power resistor between the positive and negative terminals to discharge the capacitor pack fully. If the voltage is below 2 volts, it's recommended that a shorting wire be installed between the positive and negative terminals. That prevents any voltage from building up in the capacitor pack. So to discharge the capacitor pack, it's recommended that, again, a resistor be used just to limit the flow of the current when you're discharging. The resistor that's used actually in the capacitor pack is a 27 farad 100 watt resistor. You can also get this separately from us to use as a discharge device. So you just put a couple of jumper wires, one on either end of the resistor, connect those jumper wires to the positive and negative sides of the capacitor pack, and this resistor is available from HydroMaster as part number 00013580. So connect the jumper wires from the power resistor to both sides of the capacitor pack, the positive and negative, as shown in this image here. And then monitor the voltage, either with the gauge or with the multimeter, until the voltage on the capacitor pack is down below 2 volts. Once the capacitor pack has been fully discharged, then you want to install that jumper wire between the positive and the negative terminals on the capacitor pack, and then leave that jumper wire in place until you've completed any work that you're doing on the 48 volt side of the system. And then after completing the repairs, just remove the jumper wire and the capacitors can be charged up again. To check the capacitors for damage, which you should do on occasion, the capacitors can be damaged by repeatedly overcharging the capacitors. So if the voltage on the xDrive goes above 68 volts regularly or frequently, damage could occur to the capacitors. Damaged capacitors will usually show signs of distortion to the plastic covers. You can kind of see that in that image there. You can see the side of the plastic cover there is bulged out. The capacitors, when they get overcharged, will discharge a little bit of gas, and they also get very hot. So that's what distorts the covers. It's not hazardous, it just the capacitors won't work as well after they've been damaged. And if any of the individual modules appear to be damaged, then the entire capacitor pack should be replaced. Here's a couple more images of damaged capacitor modules. You can see here same thing, is kind of bulged. You can kind of see the distortion on this one as well. So that's what you're looking for to see if the capacitors have been damaged. So maintenance on capacitors, really there isn't any particular maintenance. However, just like any other electrical components, it's good from time to time to look at the exposed electrical connections and make sure there's no corrosion, no signs of overheating, which would indicate maybe a loose connection. So those are the types of things that should be put on a maintenance schedule or routine just to check, do a visual check on the capacitors. If the capacitor module is taken out, it can be stored for basically an indefinite period of time. But that shorting wire should be installed between the positive and negative sides of the capacitor pack. So whenever it's stored, that shorting wire should be installed. Disposal, so if you actually have to dispose of these capacitors, they are composed of aluminum, carbon, and an organic electrolyte. So they're very much like batteries. There are no heavy metals, no toxic materials. So cities differ on how the materials are classified. An MSDS sheet is available for them. So you should, if you're going to dispose of them, check with your local classifications as to disposing of batteries and take care of them that way. So a little bit about the theory of operation for the xDrive. How does it all work? So it all starts with the van engine. So you start the engine, start the vehicle. As soon as you start the vehicle, or actually just turn on the ignition, the 12 to 48 volt converter becomes active and the capacitors start charging up. And again, it takes about 8 minutes to fully charge from completely discharged state up to the full 48 volts. Once the capacitor pack is charged, that then provides the 48 volts to initiate the controllers, the motor controllers. So at this point, you push the start button, and the start button initiates the elevated idle. It's called the SCIC system on the van. So the engine idle starts going up, and at the same time, the power control relay is activated, and the capacitor relay is also turned off, so you stop charging the capacitors. So the van engine's running now at high idle. The machine is starting up. The generator is starting to spin faster. It's producing AC voltage. The AC voltage is fed into the generator controller. The controller converts that AC voltage coming from the generator into DC voltage. That's provided to the motor controller. Motor controller in turn transforms that DC voltage back into AC voltage to spin the motor and the blower and the pump. And that's what turns the system. And then both the generator and the motor themselves are controlled by the controllers, but they also have a speed sensor and a temperature sensor inside each motor that's providing feedback to the controllers. That's kind of the overview of how the whole system starts up and generates power. So some of the other parts of the electrical system we'll talk about just for a minute. The vehicle power. So there's a specific point for picking up power on the vehicle. The power distribution center, or the fuse box on the side of the machine. We'll go over the plug-in relays and the fuses. We'll look at a couple of specific electrical connectors that make up the system, and then we'll look at the electrical schematics. So the vehicle power is taken from the battery. Battery on the Ford Transit is underneath the driver's seat, and they provide a power access point, or a customer connection point, they call it CCP. That's actually on the outside of on the base of the seat, so the seat pedestal. And this is not ignition power, this is battery power. And there's a post right on the side that has a 60 amp fuse that's located just inside the seat pedestal. Oops. You can see in the diagram, so this is the fuse box that's actually inside the pedestal. That 60 amp fuse on the description here is item number 1. So that's right down at the bottom. It's a large fuse that's bolted into that fuse box. It's very hard to get out, so be careful that you don't short out this post that's on the side of the seat pedestal while you're working on it, because that fuse is very difficult to work with. In this diagram, it shows actually shows 2 connection points. There's a C1 and a C2. C2 is only available with some of the options. I believe it's the dual battery. If it's got 2 batteries, they may have this second connection point, but C1 is always available on all configurations. So that's where we pick up the power. And again, this is battery power. They don't want you connecting directly to the positive terminal on the battery. They want it to go through this fused connection point just to protect the electrical systems. So that's battery power. Ignition power. So we need to we connect to the battery power, but we need to turn the power to the machine off and on. So we have to find an ignition source. They provide an ignition source also in the driver's seat pedestal, and it's a plug down next to the battery. And they've used several different plugs over the years. 2017 to 2019 was an 8-way plug. In 2020, they changed that to a 10-way plug, and prior to any of this was a 6-pin plug. But they've always used, which is nice, they've kept at least some consistency. Pin number 6 is always the ignition pin. So when we put the machine together, we have the plug that actually mates with this one, and we've got a wire connected to pin 6 on either the 8-way in the 2017 to 2019 or the 10-way starting in 2020. So we've plugged into that, and then we have a relay that the machine turns off and on to turn off and on the battery connection to the machine. So just a little bit about the fuse box on the side of the machine, power distribution center. In these images, all the relay spots and all the fuse spots are populated, but in the newer models, we've eliminated some of these, so there may not be relays and fuses in all of the spots. We do use, they're called glow fuses. So you can kind of see in one of these images, this top one actually is a blown fuse. So when these fuses blow, a little LED light lights up in them. So it's a real quick way to tell if the fuse is good or not. This little light will be illuminated if the fuse is actually blown. So some of the fused circuits, we'll talk about what those fuses are. So fuse 1 is the circulation pump. That's the pump that pumps the water through the motor and the generator and through the heat exchanger. It's also the power for the throttle control. And that's a 5-amp fuse. So fuse number 1, 5 amps. Fuse number 2 was a fuse, 2-amp fuse that operated the throttle control relay. That relay was used in the 2017 to 2019 models. Ford changed the way that operates, the SCAC operates in 2020, so that fuse was eliminated along with the relay that goes with it. But fuse 2, a 2-amp, 2017, 2019, 2020 is actually blank. There's no fuse there. Fuse 3 is a 5-amp fuse just for dash lights and powering the gauges in the dash. Fuse 4 is the fuse for the pump-in pump. That's a 10 amp fuse. Fuse 5 is a 3 amp fuse for the recovery tank float switch. That's the power that runs through the switch. Fuse 6 is the 3 amp fuse for the pump clutch float and the pump clutch relay. Fuse 7 is the pump clutch itself. That's a 7.5 amp fuse. So the float switch and the clutch are fused separately. Fuse 8 is a 25 amp fuse for the pump out pump. And fuses 9 and 10 are not used currently, and they have extra fuses plugged into them. So we use two different kinds of relays. On the xDrive, we use the plug-in type that goes in the fuse box. That's referred to as a ISO 280 micro. So if you're looking to replace those, it's a 280 micro. And then just our standard relay, which is the mini. It's referred to as an ISO mini relay. So the first relay, relay number 1, is the throttle control relay. And again, that was only used between 2017 and 2019. In 2020, Ford changed the way their throttle control works a little bit, and so we could eliminate that relay. Relay number 3 is the relay for that turns the controllers off and on. Relay number 5 is the pump clutch relay. Relay number 7 is the brake interlock relay. We'll talk about that a little bit later. Relay number 9 is the main power relay from 2019 and earlier. In 2020, that CR9 is now blank. There's no relay there. And it was replaced by the relay number 12, which is now the power relay. And we have been retrofitting the machines out in the field. And so the most machines now should be retrofitted with CR12 instead of CR9. Relay number 10 is that vehicle power relay talked about down at the battery when to switch the battery power based on the ignition. That relay is down mounted next to the battery, as close to that customer connection point as we can. And then CR12 is the new main power relay. CR13, so relay number 13 is the relay that's in the capacitor pack. That's what turns the charging circuit off and on. So just a little bit about the fuse box. The pins in the fuse box can be removed if you need to repair them or remove a wire or add a wire. But to do that, you have to remove all the components. So you pull all the fuses out, pull all the relays out, and then you can, in this image on the left here, you can get a little tool, a little screwdriver or a little tool, and pry off this faceplate. And then once this faceplate comes off, then all of the individual pins are exposed, and you can unlock them by putting something in next to the locking tab, disengaging that lock, and then the pin will pull out from the back. We use a couple of different kinds of connectors on the machine. We've tried to standardize these as much as possible. One of them is the Deutsch Connector, and all the pins on these are all the same size. They're all size 16, either the male or the female, all size 16. These connectors are nice because they're watertight. They're sealed. If one of the positions isn't used in the plug, there is a sealing plug that goes in there to maintain that watertight connection. And they're really very easy to use. They're very simple to put together. The crimping tool is very easy just a very, very nice connector, and we've had real good success with these. The other type of connector that you'll see on this machine that's unique is the plug that plugs into the controllers. This is a 35-pin plug made by Amphenol, and there are some very specific ways about how you unlock it and how you insert and remove wires. It's a real good video by the company that makes them on how to do that, how to unlock it, how to push the wire in, the terminal in correctly, and then how to re-engage the lock. So I really encourage everyone to watch this video on the proper use of these. One of the other things I just might mention while I have this image up here, care needs to be taken if you're testing with this plug. It's really not recommended that you probe these points. This is the end of the connector, the terminal. If you probe them with a lead from an amp meter or a multimeter, real easy to damage them. It will expand the pin so that it doesn't make a connection or makes connection intermittent. So really not recommended that you probe them. We do have the mating part to this, and that actually works very well. You can plug that in. You remove this from the controller, you plug in this other, the mating piece, and then you can probe the back of that, and that prevents any damage to the plug. So I really recommend that as well. So now we're going to look at the schematics, just some of the, again, the fused circuits and a couple other circuits, just to kind of get an overview of how these circuits operate. So these are, they follow the fuses. So fuse number 1 is the recirculation pump and the SCIC, so throttle control, power to the throttle control, but also to the recirculation pump. Circuit number 2 is the SCIC relay, or the throttle control relay circuit for the 2017 through 2019. So look at that. Circuit 3 is the dash power. Circuit 4 is the freshwater pump, switch, and the pump. Circuit 5 is the recovery tank float, and then the power back to the controller power relay. Circuit 6 is the pump clutch switch, float, and the relay. Circuit 7 is the pump clutch itself. Circuit 8, pump out, pump switch, relay, and the float. And then circuit 9, parking brake interlock. 10, we'll look at the 48 volt DC circuit, and then 11, we'll look at the AC circuit. So this is circuit number 1. You see there, fuse 1 powers the recirculation pump, and also it sends the signal to the throttle control on the van. Circuit number 3, so I've jumped over 2 on this one, but circuit number 3 is the dash power. So that's just the power to the lights and the hour meter and the temp gauge. Circuit number 4 is that 10 amp circuit for the pump in pump. Goes through the switch and then provides power to the pump. Circuit number 5 is the circuit that actually turns the controllers on and off. That's sending power through the recovery tank float, and then depending on the position of the float, either turns on the vacuum light if the water level in the tank is too high, or provides power to the relay number 3. Circuit number 6 is the pump clutch switch. So we run the power for the relay through the switch to the float switch. So the only power that's going through the switch and we've tried to do this on most of these, is power going through the switch only operates the relay. It doesn't operate the component directly. That's to prevent kind of wear and tear on the switches themselves. Circuit number 7 is that 7.5 amp fuse that is powering the clutch. So when the relay switches position, that provides power to the clutch, or if the float switches, if there's no water in the water box, it illuminates the low water light. Circuit number 8 is the pump out pump. Now the power, again, goes to the switch and then to a relay, and the main power for the component, in this case the pump out pump, is actually provided from the battery. We do also provide a circuit breaker closer to the battery to protect the wire from the battery to the pump out pump. That's circuit number 8. Circuit number 9 is the brake interlock. So this is the power through the on-off switch, and then based on the position of the parking brake in the van, the power will either be fed back to the main power, so that's just what turns the machine on and off, or if the parking brake isn't set, the power will be directed through this flashing relay. So that's where you get, if you turn the machine on and the dash lights and the just flash off and on and the machine doesn't start, that's because the parking brake hasn't been set. Number 10, so this is the charge circuit. So this is the converter here. So from battery power, ignition power, we're converting it to 48 volts, and we're charging up the capacitor pack. So on the positive side through this relay, we're charging the positive side of the capacitor pack, and then the negative side back to the converter. It's got that other 7.5 amp fuse in it. This also provides power up to the power control relay. So this is this is all 48 volts DC. You notice on relay number 3, the 12 volt side of the relay, so the power side of the relay is 12 volts, but the contact side of the relay is 48 volts, and that's how we turn the controllers off and on. And then the AC circuit, you can see diagrammed here. From the generator, you have the 3 legs, the 3 AC phases. 2 of the phases, phase 1 and phase 3, are interrupted by these solenoids. Those solenoids are controlled by the generator controller. You can see contactor number 1 is operated by pin 3 and pin 4, and solenoid 2 is pin 11 and pin 12. So then that comes to M1, M2, and M3, and off of the motor controller, M1, M2, M3 again, and again the 3 phases to drive the motor. You also see that this is the DC side, so B plus, or 48 volts positive, 40 volts negative. Also power for that meter in the front, and then the power for the tachometer. So those are the circuits. So I'll cover just briefly the plugs on both the generator controller and the motor controller, and what each pin is connected to. So the motor controller, both controllers, this is the layout for the pins. They're numbered actually on the plug, you can see it, 1 through 12 on the first row, 13 through 23 on the second row, and 24 through 35 on the third row. So looking at each of these pins, pin number 1 is the main controller power. That's the power that we switch off and on with the relay to turn the controllers off and on. Pin number 3 is contactor number 1. That's the negative side of the contactor. Pin 4 is contactor 1 positive, so that's positive voltage to the contactor. And those are 48 volt contactors, so it is direct 48 volt DC power. Pin number 6 is the power out of generator controller going to the motor controller. So the generator controller actually powers the motor controller. Pin 7 is the auxiliary light that's mounted next to the fuse box. That's the power for that. Pin 9 is the ground for the speed control switch. So each of the 4 positions, this is the ground for those. Pin 11 is the other contactor, listed as contactor 3 here. Pin 11 is the negative, and pin 12 is the positive power for those contactors. Pin 13 is part of the communication. That's the CAN pin. This is the CAN high. This is the one that goes to the computer port and then on to the motor controller. Pin 15 is from the encoder on the generator. This is the negative side of the encoder. Pin 15. Pin 16 is again the communication. This is the CAN high. This one is the one that goes to the tachometer. So it's 16. 18 is the mid-speed input. 19 is the boost speed input. 21 is the sine input from the encoder. So it's part of the speed signal. 24 is again the communication, the CAN. This is CAN low, and this is also the one that feeds the computer port and the motor controller. Pin 26 is power to the encoder for the generator. Pin 27 is the other communication line to the tachometer. 28, this is a 24 volt output, and a lot of CAN communication accessories use 24 volts as their power supply. This actually powers when you plug the adapter into the side of the machine to connect with the computer. This is actually the power for that adapter. Pin 30 is high speed. Pin 31 is the economy speed. Pin 33 is the temperature sensor input that comes up with the encoder wires. And then pin 35 is the cosine, so that's the other speed input. So we have the sine input and the cosine input. Those are used to control or read the speed of the generator. So then if we go over to the motor controller, not nearly as many connections, but again, the connection number 1 is the power. This power is being fed from the generator controller. Pin 2 is, there's actually a jumper between pin 2 and pin 24. This is what they call a CAN termination jumper. So whenever you're in the communication circuit, you have to, in essence, close the loop in the CAN system. So this little jumper wire actually closes the circuit in the CAN. So pin 15, I'll jump all the way down to 15, is again the encoder. So this is the motor encoder. This is the negative, the ground for the encoder. 16 is the CAN high. So this is the CAN line coming in from the generator controller. Pin 21 is the sine signal from the motor. 24 is the other end of that jumper wire for the CAN termination. 26 is the encoder power. positive. 27 is the CAN low, or the other CAN line coming in from the generator controller. 33 is the temperature sensor thermistor, and 35 is also the cosine, so the other speed signal. This chart is also available in the service documentation. So those are the basic parts of the electrical system. Another video where we'll get into a little bit more about the specific routing, or the diagrams, the wiring diagrams. But this is an overview of all of the electrical system.